Now we are going to see the third example of Fibonacci series printing using recursion. Number of terms will be entered by the user. A function definition named FiboRec is written with a formal argument n. If the n's value is going to become less than or equal to 1, it will return n and it will finish its working. That is the termination part. In the else part, it is holding the recursive session. There it is going to return by an expression, but it's going to work up on the values Fibonacci is going to return. In the first Fibonacci calling, it is having an actual argument n minus 1, and the second one is having n minus 2. By that thing, function definition is over. Then n terms user is going to enter as an input from the keyboard. In the print statement, Fibonacci series is going to get printed. After that, we are having a for loop. In that one, I is going to start with the value 0 onwards, which is going to range as n terms minus 1 time. Each time when the I is getting a value, it will call this Fibonacci function from the print statement. It will repeat its task till it reach n minus 1 condition. In the output section of this particular program, I have entered 5 as a number of terms. So the 5 terms in Fibonacci series must be printed. So I got the output 0, 1, 1, 2 and 3. All the 5 elements of Fibonacci series are printed here. Now we are going to see the working of the Fibonacci series. At first, I value will become 0. At that time, Fibonacci will be called. In the function definition, it will check whether 0 is less than or equal to 1. We know that it is correct, so 0 will be get pushed onto your stack as the first element. Second time, I value will get a value 1. At that time also, Fibonacci will be get called. In the function definition, it will check whether 1 is less than or equal to 1. It is also correct. It will return n's value, that is 1. It will be pushed onto the stack on the top of 0. Next time, I value become 2. In the function definition, it will check whether 2 is less than or equal to 1. We know that it is incorrect, so that it will get into the else section of that one. There, the output of Fibonacci series n minus 1 and Fibonacci series n minus 2, it's going to get added up. So Fibo of 1 plus Fibo of 0. Fibo of 1 we have already calculated as 1. Fibo of 0 we know that it is 0. So 1 plus 0, 1. That is going to become the output of Fibonacci of 2. It will be get pushed onto the top of the second last element. That means 1. Then I value will become 3. In the function definition, it will check whether 3 is less than or equal to 1. It is incorrect, it will get into else part. There it is going to call Fibonacci of 3 minus 1 and Fibonacci 3 minus 2. That means Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 2, you know that it can be split into Fibonacci of 1 plus Fibonacci of 0. Fibonacci of 1's output, we know that is 1. So it will be get added with this particular thing. So the Fibonacci of 1's output is 1 plus Fibonacci of 0's output is 0 plus 1. Our answer is going to become 2 for this Fibonacci of 3. It will be get pushed on the top of the last one. Then I will become 4. That's going to be the last condition of this for loop. So Fibonacci of 4 is going to get called, and in the function definition, it will check whether 4 is less than or equal to 1. It is incorrect, it will get into else part. There Fibonacci of 4 minus 1 plus Fibonacci of 4 minus 2 is going to work out. That means it is Fibonacci of 3 plus Fibonacci of 2. Fibonacci of 3 can be expanded as Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 2 can be expanded as Fibonacci of 1 plus Fibonacci of 0. That means Fibonacci of 2 we have to again expand as Fibonacci of 1 plus Fibonacci of 0 plus the previous ones. Fibonacci of 1 plus Fibonacci of 1 plus Fibonacci of 0. That means 1 plus 0 plus 1 plus 1 plus 0 equal to 3. That's going to be the last element which will get pushed onto your stack. When this particular function is going to return back to this main section, all these elements in the stack will be popped out. So first element which we are going to get, it is 3, 2, 1, 1 and 0. So the output is going to come for the first Fibonacci of 0 is going to become 0. The next one is going to become 1. The next one is going to become 1. The next one 2. The next one 3. Likewise it will get printed on your screen. Second example which you are going to see, it's a factorial of a number. For that thing, I have written a function called factrec of n, because one value is factorial you are going to calculate. So only one formal parameter is required for this one. Within this one, we are checking whether n's value is less than or equal to 1. If it is so, it will return n, or else the recursive part of this particular function definition is going to have return n into factorial of n minus 1. Suppose if 3 is going to get evaluated, 3 into factorial of 3 minus 1, 2 is going to get called. So again, it will call the same function itself, 2 into factorial of 1, which will be replaced by 1. So 3 into 2 into 1 is going to get as an output. And in the main section, I have written a print statement, that means factorial using recursion. And the next statement, I have written a code to accept the number from the user. And while you are accepting number from the user, you must definitely check whether its value is less than 0. If it is 0, less than 0, you have to print a message does not exist. And if it is equal to 0, you have to print factorial of 0 is 1. Or else you should call this factorial function with the value a. This is the first call from the main section to that particular function definition. Now you can see the recursive output of the factorial. I have entered a value 4. Once that function is being called, I got the output factorial is equal to 24. Here you can see the working of that particular factorial function of 4. First time call came from that print statement. That particular statement is being replaced with 4 into factorial of 3. Again that same function is called, n value is becoming 3. So it will come into else part. There 3 into factorial of 2 is going to get called. Again factorial of 2 is going to get replaced with 2 into factorial of 1. Factorial of 1, it will replace by 1. So 4 into 3 into 2 into 1. That 4 is first pushed onto stack. Next 3. On the top of that one 2. At last 1 is being pushed onto your stack. But when you are going to come back to the print function, it will get popped out from the stack. So the first 1 will be popped out, then 2, 3 and at last 4. So the final result will be calculated as 24, and that will be the output which you are going to get for this particular function.